For the remainder of Chapter 11, we're going to talk about rational expressions, which I consider to be like polynomials on steroids. But that's certainly not what you're going to read if you look this up in a book. The official definition for a rational expression is an expression that can be written as a fraction whose numerator and denominator are polynomials. A rational expression is in simplest form when the numerator and denominator have no common factors, obviously except one. And to simplify a rational expression, you must factor each polynomial and divide out any common factors. One important note is that parts cannot be canceled. So for example, if you have n plus 8 and 8, you can't cancel the 8s. This is a monomial, and here the 8 is part of a binomial. So you can't cancel part of this binomial with this monomial. It has to be the entire same binomial. So I'm going to show you what's really happening when you reduce your polynomials. We have to simplify if possible, and then if there are any excluded values, we'll do that as well. So 12 is just like 2 times 2 times 3. And this is 2 times x times x. Obviously, I'm not going to do this for all of them, but this is what's really happening. I'm canceling out a common factor from the numerator and denominator, and then whatever's left is my answer. So this is going to be 6 over x squared. When you want to find excluded values, you always go back to the original. Because sometimes when you're reducing, you'll be canceling something out that's supposed to be excluded. So as we've done in the past, you take the denominator and you see what do you need to make it 0. So through some magic of inverses, the excluded value is x equals 0. So all values of x are going to work, but x equals 0 is the excluded value. Let's check out letter B. I can't really break anything down because I can't break up a binomial. I just told you that. So technically, this can't be simplified. But we do want to say what the excluded values are. So you take your denominator and you see what do you need to make it 0. So the value n equals -8 will be the excluded value. Okay. This is 3 times y times y. And this is 3 times 2 times y times the binomial y minus 7. So you cancel out a 3 and you cancel out a y. This y cannot cancel this y, just like this n cannot cancel this n, and this 8 cannot cancel this 8 because it's part of another polynomial. So that's as simplified as you can go. So the answer is y over 2 times y minus 7. And now go back to the original to figure out the excluded value. So 6y times y minus 7 equals 0. Drop the line. Y is going to be 0 or 7. And these are the excluded values. When you want to simplify something that contains a trinomial or anything more complicated than what we did in example 1, you have to factor it first. So when I factor the numerator, I get, let's see, no pun intended. Let's see, it's going to be plus 4 minus 3. I hope you all laughed at my joke there. And then this is minus 5 plus 4. And so you see this c plus 4 cancels with this c plus 4. You cannot cancel the c here because it's part of a binomial with the c here. That's also part of a binomial. So the final answer is going to be c minus 3 over c minus 5. To figure out what the excluded values are, go back to the original. And it's already factored for me. And figure out the values. C equals 5 is excluded, and also c equals negative 4 is also excluded. Now, if you look at the simplified version, if you did the simplified to figure out the excluded values, you would only get 5. You would not get the negative 4 that's also excluded. So that's why you always go back to the original when you want to figure out what's excluded. Letter B. The numerator is a difference of two squares, 1 minus z times 1 plus z, and that's z minus 1. Now you look at these and you go, these look so similar. Please, can I cancel them? And the answer is yes, but. You can cancel them, but what they leave behind, because they're not quite the same, is a negative 1. And I'll show you in class why that's the case if you want me to show. But anytime you have a binomial and it's kind of like it's just reversed order, they cancel, but they cancel with a negative 1. If it's a minus. If it's a plus, then they just cancel right away. Because we know addition, it is commutative. You can change the order without changing the value, but you can't change the order of subtraction. So that's why the negative 1 gets kind of like left behind. And again, I'll show you in class if you want. So the final answer for this is negative 1 times 1 plus z. Since the whole denominator canceled, I don't have anything in the denominator spot, but I do have to determine the excluded values. So z minus 1 is 0. So the value for z is 1. Read this example, and if you know the two formulas, write them down. So those are the two formulas, surface area and volume of a rectangular prism. And now I want to plug in the values so that way I can set it up as a ratio. So I'll call this the length, this the width. Well, technically that should be the height if I want to get specific. Height, width, and length. Okay, so 2 times x squared, I'll just cut to the chase, plus 2 times, that's 2x squared, plus 2 times, that's also 2x squared. And now I just combine. That's 2x squared plus 4x squared plus 4x squared. So the final surface area is 10x squared. The volume is going to be a lot simpler to calculate. That's just x times 2x, which is 2x to the third. So the ratio that they're telling me is surface area over volume. So that's going to be 10x squared over 2x to the third. When you simplify 10 divided by 2, you get a 5. And when you simplify x squared divided by x to the third, you'll get 1x left over on the bottom. So this is going to be the answer, 5 over x. Now, when we talk about excluded values, right, that would be 2x to the third equals 0. So through the magic of inversing, that would give you x equals 0. But that's like a little ridiculous because that would mean that the length doesn't exist, right? Like, which would mean that you don't even have the cube. Or it's not a cube, it's like a prism. So you wouldn't even have this block of ice if x is 0. So that's kind of like a little ridiculous to state. So we're just going to leave it as 5 over x. And also, they didn't really even ask for the excluded values.